Dear students, we'll now look at ratio test. Ratio test. The full name for this test is actually D'Alembert's ratio test. What this test says, let's see the statement first. If sigma un is a series of positive terms, and limit of un plus 1 by un, that is n plus 1th term and nth term, the ratio, if the limit is equal to some L is a real number, then three situations. We can say that sigma un is convergent if L is less than 1, and we can declare that sigma un is divergent if L is greater than 1, and if L comes as 1, the test fails. The test fails to decide the nature, of the series. Means we will not be in a position to tell whether the series is convergent or divergent. We have to apply for some other test. Generally, when ratio test fails, we apply Rebus test. Now let us quickly try to solve a problem on ratio test. Test the convergence. Test the convergence means check the convergence, whether it is convergent or not. Convergence of the series. Sigma n square divided by n factorial, n is equal to 1 to infinity. Solution. Given series is sigma n equal to 1 to infinity, n square divided by n factorial, I call this as sigma un. Say, implies un is going to become n square divided by n factorial. Whenever factorials come in the numerator or denominator, the best choice is ratio test. So because factorial is present here, I go for ratio test. Now I change the color to say you that the step is changing now. Now un plus 1 is the next term, that is n plus 1th term. In the place of n, I am substituting n plus 1. So this will become, okay, n plus 1 whole squared divided by n plus 1 factorial. Implies un plus 1 by un is equal to n plus 1 whole squared divided by n plus 1 factorial into, the un gets reversed now, okay. So this will become n factorial divided by n square. Now we have un plus 1 by un. What I now do is, I'll calculate the limit of this one, but first of all let us simplify this. It's better to have a simplified version for this one. N plus 1 into n plus 1 into n factorial divided by n plus 1 into n factorial into n square. Now this n factorial gets cancelled, one n plus 1 gets cancelled. We'll be having n plus 1 divided by n square. Now un plus 1 by un is n plus 1 by n square, and it can be very easily written as 1 by n plus 1 by n square, just as separated. We have to bring in such a form that limit calculation becomes easy. Now, okay, I'll change the color. Now limit limit as n tends to infinity for the expression un plus 1 by un is limit n tends to infinity 1 by n plus 1 by n square. So after separating the limit, we will be getting 0 plus 0, that is finally 0, and that 0 value is very important here. Whatever limit comes, that is important. So that limit is less than 1. Therefore by ratio test given series is convergent. I hope you understood. Whenever the factorial comes, we will be applying this particular ratio test, and factorial actually fundamental. Okay, the fundamental point is that concept of factorial n factorial is nothing but 1 into 2 into 3 so on up to n. Instead of factorial, sometimes what happens, un will be having the terms like 1, 3, 5 so on up to 2n minus 1. This so on is appearing here. This so on also is a concept of factorial. It is like factorial. So in this particular case, we use ratio test. Now let me demonstrate another problem on this particular ratio test. We will have quickly another problem. Test the convergence of the series sigma n is equal to 1 to infinity 1, 3, 5 so on up to 2n minus 1 divided by 4, 7, 10 so on up to 3n plus 1. Now in this case, what happens here is, I am not writing all these details. So un is nothing but 1, 3, 5 so on up to 2n minus 1 divided by 4, 7, 10 so on up to 3n plus 1. This so on concept should give you the feeling that we have to apply ratio test. Implies un plus 1 will be replacing n in the place of n plus 1 in the place of n. So 1, 3, 5 so on up to 2n minus 1. The other way, un will be this one with extra factor. Extra factor comes here, and 2n minus 1 should be written as 2 into n plus 1 minus 1, that is nothing but 2n plus 2 minus 1, that is equal to 2n plus 1. So this is 2n plus 1. Now every factor is having a difference of 2 units, you can see, and this difference before this 2n plus 1 will be 2n minus 1. So the other way you can see in that way. So the point is that, okay, now this complete divided by 4, 7, 10 in the place of n. If I write n plus 1, I will be getting 3 into n plus 1 plus 1, that is 3n plus 4. So this last one will be 3n plus 4, and before 3n plus 4 there is a difference of 3 units here, so it will be nothing but 3n plus 1, and it is exactly what we have taken here. So this is the way you can take some step without calculation, directly you can write in that way. Now un plus 1 is this one, therefore limit as n tends to infinity un plus 1 by un. Now it is just a simple tricky step. This will come reverse after cancellation. What happens, okay, let me write it better, 1, 3, 5 so on up to 2n minus 1, or it takes a lot of time to write it, so I am trying to save time. So this un plus 1 will be there, and this particular un will be reversed. So this 1, 3, 5 will get cancelled. 4, 7, 10. 4, 7, 10. They all get cancelled. So what remains is, because the numerator is un plus 1, so the term from the numerator remaining will be 2n plus 1 and 3n plus 4 in the denominator. Remaining all things will get cancelled. I hope you understood this one. Okay, I'm sorry, I have to rub this one and I have to write limit also. So that is nothing but limit n tends to infinity 2n plus 1 divided by 3n plus 4. Now to find the limit, we cannot substitute infinity here. We need to divide with n. So limit n tends to infinity. This will be 2 plus 1 by n divided by 3 plus 4 by n. And when you separate the limit for the numerator and denominator, it will be 2 plus 0 divided by 3 plus 0. That's equal to 2 by 3. This value is important and it is less than 1. Therefore, by ratio test, given series is convergent since the ratio is the limit is less than 1. I hope you understood. Thank you.